The egg drop experiment is a classic science activity that not only tests engineering skills but also provides a tangible demonstration of Sir Isaac Newton's laws of motion. This experiment, where participants design structures to protect a raw egg from breaking during a drop, offers a hands-on way to understand the concepts of inertia, gravity, and force. Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an external force. This principle is directly relevant to the egg drop experiment. When the egg is at rest within its protective structure, it will not remain at rest until an external force, like gravity. The egg drop experiment goal is to design a structure that minimizes the impact force on the egg, thus preventing it from breaking. Newton's second law of motion describes that relationship between force, mass, and acceleration also plays a crucial role. The force exerted on the egg during the drop is directly proportional to its mass and the acceleration it experiences due to gravity. By designing structures that increase the time over which the egg comes to rest, students can effectively reduce the impact force and increase chances of the egg surviving the drop. This can be achieved through various design strategies. Materials: raw egg, piece of paper, bubble wrap, scotch tape, metric tape. Step 1. Roll the egg on a piece of paper. Step 2. Roll it on a bubble wrap. Step 3. Wrap around with tape to tighten the wrapping and ensure to prevent the egg from cracking when it falls to the ground. Step 4. Drop the egg from the building. Step 5. Unwrap the egg and see if it cracks or not. Finally, our experiment was successful. Our egg did not crack as it falls from a 17-feet building. Problem: an egg wrapped in bubble wrap to prevent it from cracking as it falls to the ground is dropped from the top of a building with a height of 17 feet. Calculate the average velocity of the egg as it falls to the ground and determine the time it takes for the egg to reach the ground. Consider the acceleration due to gravity as g equals 32 feet / s superscript 2. This problem involves the following steps. Point 1. Consider the protection provided by the bubble wrap to ensure the egg does not crack upon impact. 2. Calculate the final velocity of the falling egg using kinematic equations. 3. Use the final velocity to determine the time it takes for the egg to reach the ground. 4. Calculate the average velocity of the falling object. Let's proceed with solving this problem. To solve the problem of an egg wrapped in bubble wrap to prevent cracking as it falls from a building with a height of 17 feet, we need to consider the protective impact of the bubble wrap. The bubble wrap reduces the impact force experienced by the egg, helping to protect the IT during the fall. Here are the calculations based on the given scenario. Given height of the building, h equals 17 feet, initial velocity, 6 equals 0 feet / s, bubble wrap factor reducing impact force, equals 0.8, 20% reduction, that acceleration due to gravity, g equals 32 feet / s superscript 2.
Time taken to fall with bubble wrap protection. Time to fall is equals to a squared of twice the height over gravity times bubble wrap factor. Time to fall is approximately 1.1524 seconds. Final velocity of falling egg with bubble wrap. Final velocity is equals to the square root of initial velocity squared plus 2 times gravity times height times bubble wrap factor. Final velocity is approximately 14.7513 feet per second. Average velocity of the falling egg with bubble wrap. Average velocity is equals to final velocity plus initial velocity over 2. Average velocity is approximately 7.3757 feet per second.
Conclusion: Therefore, we conclude that with the protection dot provided by the bubble wrap, the egg will reach the dot ground in approximately 1.1524 seconds and have an dot average velocity of about 14.7513 feet per second to ensure it does not crack upon impact.